next up we look at this mess. Okay, so here's what we had in there. We had that type of chevron seal, almost kind of like a rubber cap. And then this material, another one of that, another one of that, another one of that, 4 of those, and then this big backing thing. So what did the good people at Mechanics Bliss give us? They gave us this solid looking ring, one of those, one of these, 2 of those, 3 of those, this rubber looking thing, 4 of these. Oh, that's different. Oh, wait a minute, hold on, what do we got here? This is solid, these aren't. This is different. What do we got here? That. Oh, okay, that. 1, 2, 3. Alright, so we got these 3. Look like these 3. Let's do it this way. Old up top, new down bottom. Then we got, alright, this one, it's deformed, but it looks like this one. Alright. And there's this and this. This is this. So then this big mess right here is, oh okay, it must be this gets put together with this to make that. Well, I don't like this. Oh, we got another potential problem here. I think when we took this apart at Gary's, what was in there for seals and everything was pretty shredded. But it almost seems to me like I think there might have been remnants of an O-ring that went in this groove. How critical that's going to be, I don't know. I wonder what the, since I am lucky enough to have the parts manual from the original Ware setup, I wonder what that shows. Alright, so according to the instructions here, it wasn't evident right away, but when I read through it the second time I realized that, yeah, they make reference to an O-ring. So it looks like the O-ring goes in this groove, and then when this is tightened down, the O-ring is compressed in between this discolored area right here and in the groove to create a seal. So apparently nothing seals between that edge and there. So I guess any oil that works its way down that bore is stopped by the compressed O-ring, which I'm assuming that they're figuring it'll be a negligible amount, otherwise they wouldn't rely on just an O-ring to do it. But disassembly of Ware cylinders, clamp the cylinder in a vise, loosen top nut. That's this. It's interesting, they almost talk about the top nut as being a separate piece than the ring here. Clamp the cylinder in a vise and loosen top nut. Pull complete piston rod assembly out of cylinder. A hex nut is heavily staked to the piston rod. Grind or file off stake indentation from end of piston rod to prevent seizure before removing nut. With spanner wrench, remove compression ring from piston rod. So that's almost like they're saying, again, like that like this would be a separate piece than this, but it's not. Okay, so they're talking about this is the compression ring. Let's see. At that point, the piston head packing, and top nut, with top nut packing, gland nut and wiper can now be removed from the piston rod. That's where we had all that stuff off. It talks about blah blah blah. Replace the O-rings, the packing, and wiper with new parts. Assembly of the top nut. Clean all the parts thoroughly and lubricate with a film of oil for easier installation. Install packing and top nut. Talks about what we talked about, the chevrons, making sure which way they go, what side the solid rubber filler is supposed to be on, all that. Install and tighten the gland nut only enough to prevent leakage. Excessive gland pressure will distort the cross-section of the rings and will reduce their sealing efficiency. So we don't want to do that. Goes on to say the gland nut should not protrude over 1/16 of an inch past the top nut. We'll have to check that later. Install wiper in gland nut and O-ring in top nut. Okay, so that's the wiper that they're talking about. And the top nut O-ring they're talking about is this one, which was a flat piece of rubber when I took it apart, but maybe it was just a completely compressed and squashed out O-ring. Either that or the previous people put the wrong thing in there. Install the top nut assembly on the piston rod. That's what we did there. Install piston head on piston rod, making sure it is well seated. So this is the piston head onto the piston rod. Make sure it's well seated. Install piston head packing on piston head as shown on cylinder parts diagram. And it says important, arrange packing as shown. See cylinder parts diagram for packing arrangement. Now, oddly enough, I've been through this whole book twice and I cannot find the diagram. All I can find is this list in the back here, which this particular list is for the bucket control cylinder assembly. And then there's different ones for all of them. There's the dipper stick, there's the lift cylinder. So we want the bucket control cylinder assembly, and down here at the bottom it shows a little diagram and it says the piston head packing installation, and it explains that this is the compression ring, and it goes on to show how these are all installed. So that's interesting because they're showing the compression ring. Let's see, so that's going to be this. It's showing it this way. And it's showing the chevrons facing, the points of the chevrons facing that way. So where's maximum pressure coming from? Hold on a second. As I stopped to ponder this question, I just realized how silly I must have sounded before when I was talking about what side is the pressure coming from when I was installing the top packing. Obviously the pressure is coming from this side. There is no pressure on this side. This is atmospheric pressure out here. So all your pressure is coming from this side. So all of those chevrons points should have been facing up when I installed them in here. And I'm going to have to double check that on video because I already forgot. But I'm pretty sure I got it right. Well, that explains why they don't give you a diagram for the top nut packing, because they figure you must know how to do that. This is, on the other hand, completely different. They give you a different diagram for each cylinder. Depending on which way the cylinder is under the most stress, that's going to determine which way these chevrons seals are put in. But I think this is counterintuitive to what it should be. Alright, just got back from the hardware store where I was able to procure the correct size, nice fitting O-ring in there. It's just proud of this surface, which is perfect because that means when I tighten this down on it and that surface presses on it, it's going to compress the O-ring in there and make a good seal. Alright, so I was able to figure out how this old setup went together. It went on like this. I've got everything reassembled temporarily just to show you that this ring goes on first, and then the chevrons go on facing this way. So this back cupped section is facing towards the compression ring, and that makes perfect sense because we are under maximum pressure when the cylinder is extending, and that means that this back side of the chevron is being pushed. What's happening is pressure is pushing this ring, and that's going to make this seal even tighter. So that's the design. But also what's interesting is you've got this ring first, then you got one of these chevrons, then we've got the rubber one, then another one of the other material chevron, then a third of the other material chevron, and then the backing ring. So you get the backing ring, there are 3 chevrons of whatever this weird material is, and then there's a rubber one. So the question is, where does the rubber one go? The best that I can ascertain from the picture here is back on one of these other pages. Yeah, right here, there's a diagram, and it shows that this is an assembly of 1, 2, 3, 4, 5, 6 separate pieces. 1, 2, 3, 4, 5, 6 separate pieces. And then it goes on to say that it doesn't label all the pieces, but we know that that's going to be that very top piece there. That little piece right there is going to be this. And then it tells us right after that is number 4. It says a chevron with filler installed in intersection. Well, none of these chevrons appear to have anything making me think it's a filler, so I think they're talking about something else. And then the key here is number 5, rubber type chevron wiper ring. Well, this is the only one that's kind of a rubberized material, so that's why I think the way this went together was this ring, a chevron, a rubber ring, a chevron, backing ring, which would make a sandwich that looks like that. And I'm pretty sure that's what we had on there before we took it all apart. So now the mystery is, what do we do with this? Because this, we have 1, 2, 3, 4, 5, 6, 7 pieces. This, we know this is going to be this. It's a little bit smaller. So I'm assuming that maybe that's why I got another piece here to make up for the difference in thickness of these two. See? So this is going to go on here. Then we put on one of these type of chevrons. This is like that. It's almost like some kind of material that's almost like permeated with rubber, but it's really tough stuff, like a tire. So next, if we go by the original playbook, we should be putting the rubber style chevron, which is this one here. Next, if we did it by the old way, we would put on the 2 other chevrons, seals, and then the backing ring. So the question is, where do we put this? So what I've decided to do, because I don't know, is I've decided that I'm going to put on one more chevron, then this ring, then the other chevron, then the backing ring. Alright, it's after supper. I just tightened this down as tight as I can tighten it with my breaker bar and a helper pipe on there, and I restaked it. Now I'm ready to install it back in the bore. The trick is, because these are flared out, it's hard to get them past these threads without the threads actually cutting and damaging the new seals. So the key here is a lot of lubrication, and then also what they recommend in the installation manual and the wear manual is that you cut a piece of thin shim stock. I don't have any shim stock, so hopefully this piece of sheet metal I cut will do the trick.